Okay, question 5. I knocked the camera, so I've had to start question 5 all over again. And I'm going to use the full sheet of paper because there's quite a lot of working out here and it all gets a bit of a mess. So question 5 is about Thomas looking at the relationship between the temperature of hours, between the temperature and the hours sunshine. And he records them, and so sunshine, the X for this is going to be the sunshine, hours of sunshine that he calls S, and the Y for this is going to be T, which is the temperature. So the temperature. Temperature. Okay, and that's T. Okay. So, and then he's given us loads of formulas that he's already worked out, or data that he's already worked out. And so for part A, we need to calculate the S of SS. Okay. So we know the S of SS from our tables equals the sum of x squared, or we're going to say s squared, minus the sum of s, that'd be squared, divided by n. Let me write down what n is here as well. N equals the size of the sample was 9 days. Okay, so n equals n. So the sum of s squared they've given us in the tables is 44.22. 44.22, and then we're going to take away from that the sum of s, which they also gave us as 15, and then divide it by n, which is 9. So if we calculate that, that gives us 19.22. 19.22. And do you know what? I'm going to highlight these because I know later in the question we're going to need this information again. Alright, so I'm going to just highlight those so they stand out a bit more. Okay, so question B, part B, is, and then say that Thomas calculated the product moment correlation coefficient to be 0.832. So basically, they've done all the work for us and they've said that R equals 0.832. That's very kind. So that's the relationship between sunshine and temperature. And then they say, and that's to 3 decimal places, they say, state, given a reason whether or not this correlation coefficient supports the use of a linear regression model to describe the relationship between temperature and hours of sunshine. Well, of course it does. This is almost 1. So it's a very strong, positive relationship because, let's write as much waffle as we can here for the examiner, because R is almost equal to 1. Alright, so, and that's therefore showing that they're both affected. Just one goes up, so does the other. Alright, then for part C, he says, state, given a reason why the hours of sunshine would be the explanatory variable in a linear regression model between these two. Well, okay, it's because obviously if it's sunny, the temperature gets higher. Okay, so the temperature is affected by the sunshine. So we're going to write that here. Temperature is affected by sunshine. Okay, it's a nice sunny day, it's going to be warmer. And so now we're getting on to D. Now we're getting on to where we're doing a bit of number crunching, because all of that was quite straightforward. So for part D, find the S of ST. S of ST equals, well, we can go to our tables, and the S of ST is the sum of ST This is quite confusing because take away the sum of s times the sum of t all divided by n. Alright, now they haven't given us this s of st, so they haven't given us the values of s or t, they've just given us what the sum of them both is. So we're going to have to work this bit out. It's quite naughty, and I've not seen this before where they've done this, so it's a bit tricky. This is going to be an unknown, so I'm going to keep that. So here, the sum of st minus, we know what these are, sum of s, they gave us at the beginning, sum of s is 15. They also gave us the sum of t, which was 127, and we know that n is 9. And now we're going to have to try and find a way of finding out the sum of st. Okay, that's not going to help. This may help us. They've given us what r equals. Let's have a look at what the formula would be to find r. So we go to our formula tables, and to find r here, we know that we need to know the s of xy divided by s of xx divided by times the s of yy square rooted. So that formula is going to help us because they have told us that this equals 0.832. So let's write this down. So we know that r equals the s of st divided by the square root of the s of ss times the s of tt. Alright, and we know that from our tables here. We know that from there. And we also know that that equals 0.832. 0.832. So this is the only unknown we've got here, which we're trying to find out. We know what both of these are. I think they've already told us. So let's solve it. S of st divided by the square root of s of ss, we found out up here was 19.22, times s of tt, they gave us in the tables as 10 at the top of the page as 10.89. They gave that to us in the question. Okay, and that equals 0.832. Okay, so now we just need our calculators. Here we go. So we're going to have the square root of 19.22 times 10.89 equals square root of 19.22 times 10.89 equals, right, thank you, times 0.832 equals, so we know that s of st equals 12.03688 blah blah blah. Right, I'm going to highlight that as well. These questions, they just get a bit messy with all of these working out everywhere. So, that's D. Did we have to round it? No, we didn't. But I'm going to write down here anyway. So that equals 12.04. Okay. Right, so E. Calculate a suitable linear regression equation to model the relationship between midday temperature and hours of sunshine. E. So we want a linear regression model. So here we go. We know it's going to be this here, the regression line. Okay? We know it's going to be this. So it's y equals a plus bx. Let's write that down. Y equals a plus bx, where a equals y bar minus bx bar, y bar minus bx bar, and where b equals sum of xy divided by the sum of xx. Sum of xy divided by the sum of xx. Sum of xy divided by the sum of xx. Okay, let's get plugging in. Got to find b first because a is dependent on b. So b equals sum of xy, that's the sum of st, so that's here 12.04 divided by sum of xx, that's the sum of ss, we found out up here is 19.22. So b equals 12.04, let's do it here, 12.04 divided by 19.22 equals 0.6264. And lots of other numbers. It goes on forever. Well, we think. So that's B. A, I need to know what Y bar is. Hang on, underline B. That's B. This. Y bar is the average of T. So we know that the sum of T they gave us is 127. 127 divided by 9 equals 127 divided by 9. 14.1 recurring, and x bar, that's S, the sum of S was 15, 15 divided by 9, which equals 15 divided by 9, 15 divided by 9, 1.6 recurring. Okay. Now I can plug it back into my A, so A equals Y bar, that's, I'm going to keep it as a fraction for now I think, 127 over 9, because it's kind of a recurring number, minus B, which is another recurring, but we'll keep it as 0.6264 times 15 over 9. That's going to equal, let's put this in. Right, bracket, 127 over 9, bracket, oops, bracket, take away, bracket, 0.6264 times 15 over 9, bracket, equals 13.06711111. 13.0671. Going on. Right, so that's A. Let's highlight that. A is this. So our regression line then is y equals, just getting them off the page, so therefore y equals, okay, A, which is 13.067 plus B, which is 0.6264 times x. Okay. And in our case, that's T equals, and that is the S. Okay, good. Okay, here we go. So moving onward, that was E, that took ages, and that was worth, I don't know, how much was it worth? 3 marks? 4 marks, okay, 4 marks. F is saying, calculate the, Calculate the standard deviation. Okay, wasn't expecting that. Okay, standard deviation, well, we know that, sorry, the standard deviation squared is the same as S of x divided by n, so that's the S of SS, which is 19.22 divided by 9, and that equals 1.46. That's easy. It's kind of thrown in there. Oh, 1 mark. Right. G, look how much paper this is taking. G, look how much paper this is taking. Right. Thomas uses a model to estimate 5 hours of sunshine. Right, so we've got 5 hours of sunshine, so i.e. if x equals 5, what is the temperature? So we're going to use our model here. So we've got temperature equals 13.067 blah blah plus 0.6264 blah blah times 5. So the temperature then would equal, let's pop this in. Oh, it's still got T there, so let's keep that, plus 0.6264 times 5, 16.19. I'm going to just stop that a minute. Okay. Right, so the answer to that is 16.19911, which is 16.2. So that means the temperature would be 16.2 when we've got 5 hours sunshine. Interesting. And then finally, very last question on this lot. Oh, so tedious, aren't they? And so boring, these ones. Right, so comment, given that the values of S are all within 2 standard deviations of the mean, comment giving your reasons on the reliability of this estimate. I think, right, so we've got minus 2 lots of standard deviation. So they're saying it lies within this. So the value of so I'm going to put the mean and is there. Okay. So, and the mean of x is, where did I write down the mean? The mean of x was 1.6. So, 1.6 recurring, not to forget, less than 2 lots of a standard deviation. With a standard deviation we worked out for 1 mark somewhere, didn't we? Oh, it's here, 1.46. 2 lots of 1.46, 2 times 1.46 is 2.92, 2.92, and don't forget that's plus and minus 2 lots of that, minus 2.92. So here we go. So 2.92 plus 1.6 is 4.52, and take it away. 1.6 minus 2.92 equals 1.6, well, 1.67. So really I should round that to 1.7, shouldn't I? Really, that's not good. 1.7 plus 2.92 equals 4.62, and then we've got this one at the bottom. I don't think is really very relevant anyway for what we want. But anyway, that's minus 1.22. Okay, so we're saying that this is like the middle part of our data for the hours of sunshine, and what they've asked us to do is to say whether or not the reality of our estimate for here, if that was a good estimate or not. But if we look at where we're getting the data, we're saying that we're using 5 hours of sunshine. But here we're saying that generally the middle part of our data is between this and this. And because they're asking us therefore to find out what 5 hours is, and 5 hours is bigger than 4.62, it means it's been extrapolated and it's unreliable. So I'm going to put extrapolated and unreliable. Alright, we cannot use it to make an estimate. Unreliable because it doesn't lie within this range of data. Okay, 5 is bigger than that, it's outside the range of data and it's been extrapolated and it's unreliable. And that was 2 marks just for saying that at the end of it. So that question was hard work but kind of worth it because we could get the marks but it just took a long while. Okay, so moving on to question 6. It's the last question of the paper, but again I haven't got a written copy of it, so sorry, you're going to have work from your own written copy. So now this is question 6 on the S1 IAL June 2017. And so it's telling us there's a biased coin has got a probability of, so the probability of having a head is 0.4. That's what they're telling us. And in an experiment, the coin is spun until a head appears. If a head hasn't appeared after 4 spins, the coin isn't spun again. So it's done up to 4 times. And the random variable x represents the number of times that the coin is spun. Okay. So this is quite a hard one to get your head around, really. So what they're saying is that they roll the coin. If it's a head, they don't roll it again. But if it's a tail, they keep rolling. So they could have a tail, and then here, the final time, it could be a tail or a head. It doesn't matter, but they'll stop rolling it then when they get to that point. Okay, so there are lots of outcomes we could have, but as soon as they have a head before they get here, they stop rolling. Okay, so probability of head is 0.4 and the probability of a tail is 0.6. So it's a biased coin. Okay. And x represents the number of times the coin is spun. And then they say, for example, if x equals 3, if the first 2 spins didn't have a head, but the third spin showed a head. Right, so when x equals 3, that would mean that we had a tail, and then a head, because they would have stopped if these had been heads. But it's tail, head. That's the only way of x equaling 3. Okay. Okay. So part A says show the probability of x equaling 3 is 0.144. Okay, and I've actually kind of helped out here a bit because what we want is to have a tail, and then a head. The probability of having a tail the first time is 0.6, and we want a tail the second time, that's 0.6 again, and we then want a head. So what does that equal? Hopefully it equals 0.144. Let's have a look. 0.6 squared times 0.4, 0.144. Oh, phew, what a relief. 144. Now the problem with this question 6, is understanding what they mean. Okay, so that's 1 mark. And actually, if you understand this bit, we can kind of go on and understand the rest of it. Now they give us the probability distribution table, so I'm going to just copy that here. X So 1, 2, 3 and 4. Okay, because once they get to 4 they stop. And then they've got here the probability of x equaling x is, and they've given us 0.24 here and 0.144, which we've just proved that that is correct here, because 3 rows. So really x is the number of rows. Let me write that here, number of rows. Okay, that's what it is. That's what it means. I would imagine they're going to ask us to fill the missing bits in, but let's have a look. So part B says, part 1, write down the value of the probability of x equaling 1. So that's the probability that we just roll or toss the coin one time. Well, if we toss it one time, it had to have been ahead, because then we stop. So that's obviously going to be 0.4. And I'm going to go straight to my table and put in 0.4 here. Okay. And then part 2, find the probability that x equals, we've only got one missing, so it's going to be that, equals. Doesn't say we need to show the calculations, so we can basically just take all of these away from 1, can't we? So let's do that. 1 minus 0.4, put it in brackets, plus 0.24 plus 0.144 bracket, 0.216. Alright, because we know probabilities always add up to 1. Okay, so the answer here is 0.216. Okay, so for part C, find the expected value of x. Okay, so the expected value of x is just when we multiply each of these. I'm going to just do it here because I just think it's easier. 1 times that, 0.4, 2 times that, 0.48, 3 times this, 0 point something, and 4 times that. Let's do 3 times 0.144, 0.432, and then 4 times 0.216, 0.864. Add them all together, and that is 0.4 plus 0.48 plus 0.432 plus 0.864 equals, and I make that 2.176. So 2.176. Does this make sense? The expected number of times we are going to roll the dice is just over 2 times. And it is within my range of 1 to 4, so I'm going to assume that's a pretty good guess. Okay, part D, find the variation of x. Okay, so this is variation of x is the expected value of x squared, take away the expected value of x squared. Okay, so this is what we've already got here. So expected value of x squared is e of x squared is when I square this and times it by that. 1 squared times 0.4 is 0.4. 2 squared times 0.24, that's 4 times 0.24 equals 0.96. 3 squared times 0.144 is 1.296. 4 squared times 0.216 equals, didn't like that, 4 squared times 0.216 equals 3.456. Let's add all of those together. Plus 0.96 plus, 1.296 plus 0.456 equals 6.112. Okay, so here we go. 6.112 minus 2.176 squared equals 1.377024. Boom. Okay. So now the random variable h, this is really horrible now. I think that the last part of this paper, this question is just really nasty. So you may feel that you want to abandon it there, but I'm just going to keep going in case you felt like carrying on. So the random variable h, so now we've got a new kind of experiment going on, represents the number of heads obtained when the coin is spun in the experiment. So h can only have two outcomes. It can only have it's either going to be a head or a tail. It's got two outcomes, that's all. Because they're saying that this is now representing getting a head or a tail. That's it, two outcomes. And then it says, explain why h can only take the values 0 and 1 and find the probability distribution of h. Okay, well, it's because they've said h represents having a head or not a head. So actually I should have put here, not a head. Okay, so it can only be 0 or 1. Okay. Find the probability distribution. Oh dear. So for example, the probability of when h equals 0, the only time we're not going to have a head is when, if we look up here, going back to here, the only time we're not going to get a head is when we've done the experiment like this, tail, 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 and then another tail. And that means we haven't had a head at all. So this happens only once when we have tail, 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 and then another tail. It means we've had no heads whatsoever. So the probability of this happening is going to be 0.6 times 0.6 times 0.6 times 0.6, which is basically 0.6 to the power 4. So what is that? 0.6 to the power 4? 0.6 to the power 4 is 0.1296. So it's either going to be a head or not a head. So here on my table then, it suddenly becomes a bit easier because we're either looking for when it's not a head or if it is a head. Okay? And probability of us getting a head is not at all, is going to be 0.1296. So therefore this one, because these tables must always add up to 1, is going to be 1, take away that will give me the answer. So let's just take away 1, 0.8704. 0.8704. I think that was really hard, that question. Nasty question for 2 marks. That was not nice. F. Right, so now they're saying 2 parts here. Give us the probability of x equaling 3 intersecting with h equaling 0. equals. Right, okay, so they're saying, what is the probability of us rolling the coin only three times and not getting a head? Well, that's impossible, because if we rolled the coin or tossed the coin three times and stopped, that means that that time it must have been a head, which it wasn't, because they're saying we want it to be head equaling 0. So this is impossible. This is never, ever, ever going to happen. So the answer to that is 0. It was impossible, because if we rolled the coin tossed the coin only three times, it would have been a head on the third one. And we're saying here, but we don't want it to be a head. So that's that. Yuck. Horrible. And then for part 2, they're saying the probability of this being 4, so we've tossed the coin 4 times, intersect, so as well as h equaling 0. Okay, well, we know that this can happen now. Okay, so the probability of that we've already got. So it's a fourth roll, fourth toss, and we don't get a head. Well, then we already know that that probability is 0.1296. Okay, because we've calculated that. That is another nasty question for 2 marks. G. Last question on the paper, thank goodness. Right, the random variable s equals x plus h. And now we need to find the probability distribution. Do you know what? Is it really worth it? Sorry, that is my dog and my daughter. Okay, so there's 4 marks. Maybe it's worth it, I don't know. So let's have a look. When we have x equals 1, so that means the first roll, then h also had to equal 1, because it means that I toss the coin and I got a head. So the probability of that happening is 0.4. Sorry, ignore that. S equals 2, because it's s equals this plus s. Right, we could have x equaling 2, so I've done it twice, and in that case we would have 1 head, so s equals 3. Then we could roll it 3 times and we'd have a head, so that would be s equals 4. Then we could roll it 4 times and we could have a head, which would be s equals 5. Or we could have rolled it 4 times and not had a head, in which case s would equal 4 again. So I know that my table is going to take the values for s. The values for s are going to take 2, 3, 4 and 5. And now I've got to work out all these probabilities here. Okay, so the probability s equals s is, so when I have this one for 2, I've got to have it when the probability of x is 1, which is 0.4. Yeah, so probability of x is 1, and that's 0.4 from up above, up on my table up here. I'm going to use these values here to fill out my values down here. Don't know if I can get them all in the same place. Yeah, I can. Just get them all into the same screen. So when s is 3, and there's only one time it occurs here, it's when x is 2. So that's 0.24. Now for 4, I have got 2 possible values. I've got this one and this one, 2 outcomes. So when x is 3, from up here I've got 0.144. So I'm going to have 0.144. And I've also got this time, when this happens, when I have this. And so I've just seen, you can't see what I'm writing at the bottom here. So for the when s equals 3, I've got 2 outcomes. I've got the one for my table up here when I rolled the coin 3 times and then I got a head. So that's 0.144. Plus, I've also got, sorry, that should be when s equals 4. I've got off the screen again. When s equals 4, sorry. And I've also got that I've rolled it 4 times and no heads, and I've already worked out the probability of that is here, 0.1296. I need to add those together, which is going to give me 0.2736. Yeah, for here. Now then, this is going to be easy because I'm going to cheat again. I'm just going to take this away from 1. Just always the easiest way to do things. 0.4 plus 0.24 plus 0.2736 equals -1 is 0.0 small writing 864. Okay, 0.0. Let me write that here. 0.0864 because it's very small. Okay. And that's the end of that paper. That last question, G, was worth 4 marks, and I'm not surprised. Okay, end of the paper. Hooray! So if you've managed to get to the end with me, yay, well done. That's another paper down. Okay, see you later. Oh, let me do a happy face. Yes, let's keep working hard. Yay! Well done, everybody. Yes.